Hello, and thank you for joining us for part 2 continuation of the Unity game development with C#. In this tutorial, we're going to do a quick review of what we did. Next, we'll review some Unity editor navigation and concepts, then create a car with wheels and some tracks for us to test. As you can see in our last tutorial, we created a box and moved it around. But notice when the box collides with our cylinder, it's jittery and sometimes it's halfway into the cylinder. To understand why this behavior is exhibiting, we will need to review how the video games render the screen. It's really no different than watching a live-action movie or animation. The animation is made up of pictures, and when they are put together and displayed in a sequence, it tricks the eye into thinking we're seeing a moving object or some other scenery. In our previous tutorial, we showed you the game stats dialog where we saw the number of frames being rendered. Each frame is a picture that is displayed quickly. Now, when we moved the box, we told Unity to move the box every second. So between these seconds, Unity created approximately 800 to 1000 frames. So we simulated a box move by positioning it from location to location. By the time the frame rendered and we moved location, we ended up inside the cylinder. And notice the glitches or jitteriness, and it was not realistic physics we see in real life. Unity does have a physics system, and we've seen that by using colliders and rigid body. So does it make sense that we should be moving to rigid body or the collider? So in this scene, we have a main camera, we have our directional light, and then we have our plane, which is going to be used as our ground. We have a cube and we have a cylinder. If you look at the plane, it has a mesh collider. This is what it's going to keep any of the objects to go through it. And then our cube has a box collider, and our cylinder has a capsule collider. To get a better view of what the colliders look like inside of this mesh, we can go ahead and click this edit collider. We're not going to edit this, but it should give you an idea what this looks like. So this green line is the actual collider, and this is where the objects will interact. So if we go to our cube one, it is just encompassing the cube itself, whereas in the cylinder has a little bit of space where it's not totally covering it. Notice now we don't have anything else in here. If we run our scene and go back to our game, if we were to go ahead and move this cube, notice it just goes right into our cylinder and they're not interacting, even though they have colliders on them. Same is true if we were to go into the plane. And the reason for this is that we need one additional object in one of these game objects in order for it to work. So let's go ahead and stop our scene. We're going to choose our cube and we're going to add a component called rigid body. The rigid body has a mass and a drag and a bunch of other information here, and we'll eventually go over all of them, but for right now we can just concentrate on mass, drag, and also using gravity. So if we now run our scene and go to our scene tab, notice that our cube dropped, and now if we pull our cube, it is now interacting with the cylinder and it's causing it to do these weird phenomena where it's trying to go around and it really can't, and somehow is going underneath it, and it causes this behavior here. So if we were to bring it a little bit to the side and try to do the same thing, and notice now it's getting pushed around our cylinder. The rigid body is interacting with the world because it has mass, and the mass is 1 unit, and we'll go over that in a second. And then it has drag, and then using gravity. Using gravity means that it's now going to interact with our world, and our world is basically has a setting. So if you go to our projects settings, and if you go to our physics, notice that we have a bunch of physics attributes, and the most important one is gravity, which is negative 9.81. This is simulating Earth's gravity to pull the objects down, and this is why when you enable the gravity, the object falls and collides. Its box collider is colliding with the mesh collider, and that is what is keeping it from going through. Unity has a measuring system of metrics. So this is 1 kilo. If you were to make this 500 kilos, it would still interact with the world as is, and you'll get the same behavior. But what happens now if one mass which is greater and interacting with another mass that is smaller? How would they react? So let's add a rigid body to this as well. And we said this was 500. Let's make this 50. This time when you run it, both objects will fall because of gravity. And let's go back to our scene and grab our cube, and what should happen is that our cube should push the cylinder because its mass is much bigger, and it is able to overcome the mass of the cylinder. So basically that's in a nutshell with colliders. Colliders gives you information as well. So if we were to enable is triggered, what will happen is that if you run it, let's take a look and see, it goes right through the mesh, right? The reason this is happening is that it is now becoming an event. It's no longer going to collide with objects. And the reason this happens, or we would want to use this, is that you can have a stationary, so for example, you could have something remove the rigid body so that it becomes stationary. And then when an object collides with it in code, you can detect that and then do something with it. So if you were to go to create a racing game, what you could do is have, for example, power-ups or some kind of a finish line to where if this would be your car, and once the collision happens here, if it was a power-up, you would disable the cube, and then you would use that as, you know, giving speed or jumping or something, or you could use this as a finish line, so when the car goes through, you know that the course is finished for the vehicle. So that's one of the reasons you might want to use the is trigger. So there's many options of how and why you'd want to use the trigger. Let's go ahead and add our rigid body back, and let's make it 500. There's one other scenario you have to be aware of. So let's go ahead and zoom out a little bit, and then take our box and pull it really far up. Actually, let's increase its mass to 1,000. So now it's about around 1 ton. So when it falls through, so if we go to our scene now, it went through our plane even though our cube had a rigid body. Now remember what we mentioned earlier, that when the frames are rendered, when you're using the cube and you're moving it using the transforms that we have up here, you're basically taking a cube from one place and then moving it to another place. So it's basically being rendered here, and then between those frames it might disappear and it may not show, and then when you render it again it'll show up. It's almost like disappearing and then reappearing someplace else, and this is why we saw that jitteriness where the box was inside of the cylinder. When you're using the rigid body in the physics system, what will happen is that the calculation of the physics happen within, I believe, 2 milliseconds. And so there is a scenario where you will have the object that is falling, its mass being greater and its speed, velocity being pretty fast. When it collides with another surface, if it happens between the 2 millisecond, there's a possibility that it might go through. And so the collision will not happen before it's detected. It's actually gone past the object, and therefore you see it fall down. So there are a couple of ways to fix this. The easiest one is to put drag. Now, if you're in space and on the moon and you have a bowling ball and a feather, you drop it, they both will fall at the same rate because there's no friction, there's no air molecules to keep it. On Earth, when you have a bowling ball and a feather, you drop it, the bowling ball will hit the ground first and the feather will take its time until it hits the ground. And the reason is that the mass of the bowling ball is greater and it pushes the air out, and therefore it falls, whereas the feather, it interacts with the air and it falls slower. So if we will put maybe a drag of 1 and then run our scene, and this time there's going to be a possibility of this actually being stopped with our plane, because the drag is keeping it and its velocity a little bit slower, so hopefully the calculation of the impact will happen and it caught it before the collision went through. So just something to be aware of. Let's go ahead and move our cube back down. Another thing you can do is, if you're too far away, just hold down Shift and F and it'll take you right to the object. For example, if you're find the cylinder, Shift F, the focus will go into the object in your scene. Another helpful hint is that these icons above, if you're manipulating, for example, if you hit the Q, you can use the hand tool and you can move your scene. If you hit the W, if your object is focused, you get the navigations so that you can choose the XYZ location. And if you use E, this is the rotation. You can choose which way to rotate. And if you were to use R, it will now go to resize. And if you use the T, it is going to do a cylindrical, or excuse me, it'll do a rectangular geometry on this. Y, it gives you all of these in one icon, so you can move it, you can scale it, you can rotate it all in here. Just another helpful hint, if you're resizing and you want to resize the whole object, then notice how the cursor is turning when my mouse is on this icon, and the icon in this box is turning yellow. Notice that. And if I now hold it, all the XYZ selections are being highlighted as yellow, and now if I move it, I'm actually sizing all the sides at one time. Okay, so now let's actually write some code that is going to use our cube and our cylinder, and they're going to interact using physics rather than moving the transformation of the box. So we'll be moving the rigid body, and we'll see the collisions and the jitteriness that we noticed before should go away. Before going over how to write and move the cube using the rigid body, let's kind of review some of the things that we have gone over. So if you go to Edit and then Project Settings, you have your physics tabs here that shows us the gravity. Also, it mentioned that the time it takes for the physics to calculate is 2 milliseconds, and that time is in here. So if you need to update this for mobile games that require better performance, so you could do the calculation so that it doesn't spend so much time in calculating the physics, you could come in here and update that if you wanted to. Okay, so now let's go ahead to our Visual Studio and write some code that is going to update our rigid body for our cube. So let's go ahead and associate our move cube to our box. Our move cube is in the assets. To associate this to the cube, we'll select the cube. Looks like we already have it associated, so let's go ahead and remove that and just drag it and add it. So this is, if you didn't have it, this is how you'd associate the script to that. By double clicking the script, we come into our Visual Studio. So Mono Behaviors has a few events that we need to go over. So far you should be familiar with start and update, but let's see what additional methods are available to us. So here in the documentation for Mono Behaviors, where we're inheriting from, if you scroll down, you'll notice the events. We have our start, update, fix update, and some other events that are available to us. But we can get more information by switching to scripting, which we already have available here. And as you can see, we have start, update, fixed update, late update, on GUI, many events here for us. And there are some public methods in there too. So the one that we're going to highlight is fixed update, which is used for physics. Anything we do with a rigid body, anything that has to do with the physics, we should be putting our code in fixed update. So let's go ahead and create the fixed update so we can put our physics code. Before doing that, let's go back up to the top and create some variables that we're going to hold. So we'll go ahead and create a variable for the speed of our cube. We'll make this public so that we can change it in the UI later on. 40 should be a good number. Next, we'll create one for the rotation of the cube. We'll create a vector 3 for that and keep the rotation angle at 50 for now. And now we're going to create a private variable for the rigid body. And one more private variable for our inputs. So we'll put that in vector 2. So let's go ahead to our start and wire up our rigid body by doing a get component. And the component we want is a rigid body. Now, how do we get this? Well, if you go to Unity and we associated the script to this cube, and the cube has a rigid body, when we ask get the component that is rigid body, Unity will wire up our rigid body automatically for us in that method. So now I have a rigid body that we can go and move and rotate as we please. In the void update, we will go ahead and use the vector 2 input direction for getting the horizontal and vertical axes. Now for the fixed update, we will go ahead and get our rigid body and move and rotate it based on the input that we have. We're going to go ahead and create a variable, a quaternion, and this is going to be our delta rotation. Quaternions are a system of rotation that allow for smooth incremental rotation in objects. So we'll use the Euler method, and let's go ahead and populate our values inside of this. We need our input direction of x times the rotation speed or the angle times the delta time in seconds. So this will be used when we rotate the cube. Now let's go ahead and move the cube using the rigid body. So in the rigid body, we have a method in here that can help us do the rotation called move position. In the move position, we will use the rigid body's position plus the values that we want to change. So we'll go ahead and use the transform forward times the move speed times the input direction of y. So if the y is plus, we move forward. If it's negative, we move backwards. And this is going to be times the delta time in seconds. So now that we are moving, we can go ahead and use the delta rotation variable to rotate our rigid body. And this time we're going to use the move rotation So we'll say rigid body dot rotation times the delta rotation. And this should now move our cube and rotate our cube for us as we use the keyboard up and down arrows or sideways. Let's go ahead and test this really quick. We've used a camera rig to help us out from one of the prefabs, but we will go ahead later on and create one, and that's going to simulate the same thing. But for now, it should be good enough. Go ahead and run our game. So our camera is in position. Now we can move the cube, and we can So the move speed is a little bit too fast. Let's slow it down to 20. And let's go ahead and do the rotation. We can rotate. We can interact with the cylinder. And as you can see, the interaction is not jarring and it does not go inside of the cylinder. The jerkiness of the cube itself is because of the mouse that we're using. It is not a representation of the how the cube is moving. So this was how you can move your cube using the physics. So now that we have learned how to move a box and work with a rigid body to move the box in using the physics engine, let's go ahead and create our model for a vehicle. So what we're going to do is we're going to go ahead and use a new component called a wheel collider. The wheel collider is basically Unity's answer to physics of how a vehicle wheel would work. So we would create you would have a model, and then you would have the tires, and then you would assign the wheel collider to the tire, and then add some properties, and then you can actually have a physical vehicle that you can code to drive. But what we're gonna do is we're gonna do everything from scratch. We're just gonna use box and cylinders so that there's no fancy models or anything, because we just want to understand and learn how the physics and the wheel collider works. We're not going to go over every single attribute in the wheel collider, but just the ones that you need in order to work and start off creating a vehicle. And once you get those basics, then you can easily go read the documentation and find more details, and we will go over some of them with you later on. But for now, we'll go ahead and use our cube and extend it a little bit to be a little more like a box shape, so it looked like a body of a car, and then assign 4 wheel colliders for wheels on our box that's going to simulate a vehicle. So if we go to the documentation for Unity and the physics, there's a how-to, and it goes over how to attach a wheel collider, but it doesn't really discuss, it just goes over what we're going to go over, but it doesn't tell you how to assign those and wire it up to your model and everything else, and we will go over that, as well as some of the physics attributes of what you need in order to make the car be as realistic as possible. So now that we have our cube, this is the body, or this is the car, or the frame I should say. Let's go ahead and create some empty game objects and move our cube inside of it. So our root is going to be a car, and this is going to be the frame of our vehicle. And then what we're going to do is create a new game object, an empty one, and this is going to be the root of where the colliders will reside. So just to keep all the wheels organized, or the colliders organized, so we just create that, and then create another empty game object, and this is the one is going to be the actual wheel colliders, where we can associate the wheel collider to this empty game object. So let's just call this the wheel collider front right, and then by default the wheel collider is going to go into the center. So let's go ahead, position that. Let's make sure that we get the quick view so we can have it positioned where we want it. And let's go to the Y, move it to the right front. So that's a pretty good place right there. And then now we're going to associate a collider to this by just adding a component. So search for wheel collider. So the minute you add that, you see the wheel collider looks like a little wheel associated to our empty game object, which is part of our vehicle. Let's go ahead and position it a little bit to where we think the wheel should be. And let's rename this one front left. And let's copy those guys and then move them back. So this will be the rear of the vehicle, the rear tires. And let's go ahead and name those accordingly. So now we have a vehicle with 4 colliders. And let's go ahead into our frame now on the rigid body for the mass. If you look at the tires have about 20 pounds, which is more accurate, more or less, when a car tire. And you have the springs and dampers and target position and a bunch of different things. These are by default would fit in normal vehicle. So if we were just going to create a regular car, this is what the tire values would be, which means the frame of the vehicle, the mass of it, should be somewhere about around 1.5 tons to 2 tons. So let's go ahead and make the mass of our vehicle 2 tons. Now if you don't, see what happens. The vehicle just jumps up, right? And if we zoom out, you can see the vehicle is just going up and up and up, and at some point it'll come back down and it'll jump back again. Now this happens because the springs are very, very strong, but you're telling it that it's what's pushing down on it is only 1 kilo. So that is why the spring just shoots off. It's kind of like a rubber band. If you just let it go, it's going to shoot off. So the spring has to attach itself to the suspension of the car, and if the car is not heavy enough, then you'll see this behavior. So about 1500 should be pretty good number. And now if you run it, our vehicle behaves very, very normal like a car, and we can still move it around. And it'll bounce just pretty normally, and that bounce is based on the values that you saw for the spring and the dampers, and we'll go over those in a minute. So let's go ahead and create a cylinder, and we're gonna use this as a testing platform. We're gonna rotate it so it's 90 degrees flat, and this will become like a little speed bump that the vehicle can go over. And let's actually scale this a little bit. And let's move it halfway into the ground. Let's go ahead and now scale it. Make sure it's in the right position. Doesn't have to be perfect. Okay, that should be good enough. Now we're still not going to write code, so we're just going to go ahead and move the vehicle over it. This is not how you would normally do it, but as you can see, it's having some force resistance going over the bump because it's probably too high, although it can go over it. But as you notice, it's still behaving like a vehicle. So maybe move the cylinder a little bit down so it look like a normal speed bump. And if we move the car now, it's still behaving pretty normal as it should. So now that we have the body and we have the colliders, what we're going to do now is go ahead and write some code, and then have our camera follow our car so that we can do some testing and see how the forward motion and the reverse and turning the vehicle going over this test platform we've created, see how that works and how it behaves.
So now that we have our car with the wheel colliders, let's actually write some code and have our car move. What we're going to do is we're going to select the frame and we're going to add a component, and this component is going to be a new script, and let's call this one move wheels. And create an add. So now we have our move wheels script. Let's go ahead and go to our Visual Studio and write some code to make this go forward, backward, and turn. So what we're going to do is create a public variable, and we're going to call this this is going to be our wheel collider. So it's going to make an array of the wheel colliders, and we'll just call this wheel colliders. Or we just can keep it as lowercase, or maybe even just name it wheel colliders. So the next one is going to be the torque. So we'll also keep this as public, and this is going to be a float, and the torque is going to be about 2000. Think of this as the horsepower, because this is the actual engine power. And then what we're going to do also is for create another one, float. Let's keep these private, although you could keep them public so you can play around with it if you wanted to. And then call this acceleration. For float, and this is going to be our steering, and one more is going to be our maximum steering angle. Now when you're turning a vehicle, the amount of degrees the tire can turn, because you don't want to go 90 degrees. That would be like impossible in the real world, and generally all cars are set up to have a 30 degree angle for rotation, so you can make the turn. So now that we have that, we'll go to fixed update, because remember that's where we do most of the physics, right? So we'll go void fixed update. In the fixed update, so before actually we do that, let's go to our update and actually get our acceleration and steering, right? So we want to say acceleration is equal to our input, and the input is going to be get axis for vertical, and we want our steering to be the max steering angle times input dot get axis, and this is going to be our horizontal. Okay, so now that we have our inputs from the user, we are now going to act on it. In here, we're actually going to create a, we're going to call this a drive. So we're going to create a method called drive. Let's go have our Visual Studio help us out. So now we have a drive method, and this is where we're going to put our code for doing this. Now we have 4 wheels, so what we want to do is we're going to loop through all 4. So we're going to create a for loop, right? And the length is going to be 4. And then we're going to calculate the acceleration. So the acceleration is going to be mat if clamp. And for this, we're going to actually pass it the value. So the value is going to be our acceleration. And then we're going to restrict it to -1 minimum and a 1 maximum. So our acceleration is going to be decided based on these 2 values. And we're going to do the same thing for steering. So let's just call this steer, and then it's going to be mat F clamp. So now we're going to get our steering of -1 times maximum steer angle. And the next thing we want to do is calculate our thrust for the amount of power that the engine has, right? So we'll just create another float. Let's actually move this up here, and let's call this thrust torque, and let's say acceleration is going to be times torque. So this defines the speed of the vehicle. So now we're going to select our wheel collider array, and then we look at the index, and our index is going to be the steer angle, and the steer angle is going to be the steer value. And then we want to check to see if this is our front tires, because if it is, then we want to be able to angle them properly. So what we can do is say if I and so that we're checking to see if the first two index of the this array is our front tires, and we have to make sure that once we assign this, we specify those two front being in the index position where we have it. So let's actually now go to, say, wheel colliders, and then our array I, and steer angle equals to steer. Or excuse me, this is not supposed to be if this is actually the tires, it should actually be motor torque, sorry. So it should be motor torque equals to the actual thrust torque that we specified up above there. So this is going to return our wheel colliders, so we have the forward motion. And then if our two indexes are the front tires, we're going to steer if the user wanted to have this vehicle turned. And this really should be pretty much everything. Here you could, once we added some mesh, we would have to also rotate that mesh. But for now, this should be good enough to get us going. So let's go back to our game and give Unity to catch up. So now notice that we have our public values here for torque and the wheel colliders. And if we open this, it gives us a size. We're going to say 4 because we have 4 of them. Hit enter, and then it's going to ask us for the wheel colliders that we need to add in there. So the first two we want to make sure is the front, right? So we'll go to this one. We're going to pick the front tire, and then we're going to choose the front left. So the first two indexes are going to be front, and then the rest of them can be anywhere in the back. And then we have our torque here as well. Okay, so let's go ahead and run our scene and see how our car behaves. So now we have forward motion. We can now turn backwards. So that works. And we can turn as well. And it behaves very similar to what we would expect. Now we don't have braking, so that means if you let go, the car just continues moving forward, and we'll come back and fix that. we'll have to put when the user hits X, we would actually brake, which means that we would lower the speed or the torque. And the next thing we want to do is actually put mesh instead of this, because once you run this, you're not going to see those tires. We want to actually see like real tires or something, right? So if we stop this, the way you would add a wheel in this is that one way you could do is like, well, let's go ahead and create a cylinder. And when you create this cylinder, notice that the position that we have, our X, Y, Z, right? So we have our Z going this way, and then we have our Y plane, that's for up and down, and then we have our X that goes sideways, right? If you look at that position, and now if we try to go to rotate this, let's say 90 degrees, so we rotate this to 90 degrees, and then we actually go to size this, and you would imagine, well, we now have a tire that you can put, and then we'll have to go back and turn our car, rotate it this way. -90 degrees. But if you look, things actually look a little bit different, right? So our axes are no longer pointing in the same position. If you were to wire this up to our car, you would see some very weird behavior. The tire not going to go forward like this. It's actually going to flip the opposite way, and it will be very, very odd and weird. And we're going to fix that by actually using Blender. Blender is another tool. It's free, similar to Unity, and that gives us the options to be able to design objects, or you could create anything within Blender if you have the skills. For us, it's going to be very simple. We're just going to go ahead and create a cylinder, and then make it so that we reset the transforms so that it is set correctly. So this is Blender, and what we're going to do is delete the cube, and we're gonna go add, and in here we're going to create a mesh, and the mesh is going to be a cylinder. And similar to how we were using Unity, you have move objects, you have rotate, and you have scale. So let's just go ahead and scale this. We're going to scale this down a little bit to look like a tire. And then if you go to the rotation, it would be 90 degrees in the x-axis. So let's just make sure that this is 90. There you go. And if you wanted to, you could turn it this way, 90 degrees. So whichever way you move this, when you go in to export this, you can export it as any of these objects. We're going to use the wavefront object. When you do, you can then tell it which way is supposed to be the forward, meaning that now the tire has the forward going, that would be that way, right? Which is going to be the z-axis. So you could change this to any one. You can X, Y, or Z. So if you change this and you click export, we've already done this. So let's actually go back to our Unity. As you can see, we already have that here. Now if we bring the tire or our cylinder that we have, let's hit Shift F to see where our tire is, and it's over here. And notice that our angles are now pointing the same direction. Our Z is going the same direction, our Y is going the same direction, and you can't see that because of the rotation of that, but everything is pointing the way it's supposed to. So let's go ahead and bring this back a little bit. Okay, so the next thing is to actually place this as part of our car. So this should not be part of the, let's move this cylinder which we're using for our testing. Same thing for the camera. Camera should not be there. And let's actually bring our tire into our car. So let's actually create a new game object, and just to keep everything organized, we'll call this wheel mesh, and we're gonna move our tire inside of it, right? And let's actually go look at it from the Y and zoom in a little bit and move it up a little bit, and let's look at it from X. It looks a little bit big, so let's go ahead and resize this a little bit. So I think that might be a good angle. Let's bring this up a little bit again. So let's go back up top. Yeah, that should be a pretty good place for this tire. Maybe we'll bring it a little bit closer. There we go. And then what we're going to do is we're going to do a Control D to duplicate this, and then move this to the front left. So we'll just go ahead and move this to about around, let's see, I think that's pretty close. Yep. So let's name our tires the same. So instead of calling it wheel collider front right, we just can call it mesh front right. And then the second one is going to be the mesh front left. And let's go ahead and duplicate these guys, and now move it back to about around, I think right there's a good place for it, right? Let's go ahead and rename these guys. We can call this rear, and this was rear right. And this one was rear, oh, this is right. This one is left. There we go. And just to be even more organized, let's actually bring this inside of the frame. Okay, so now what we could do is try to map our tire to be the center. It doesn't have to be perfect, but we'll try to get as close as we can. Kind of like that. So the X is on 66.7. We can do the same thing, XX.7, so they're actually centering on each other. And we'll do the same thing on the left. On the left is 6 negative, let's just make this 667, so it'll be similar. And then we'll do the same thing for this. It'll be 6 7. And then for the right one to be center, it's on the okay, let's actually go to the X. So let's change this to wireframe so we can see where we are. And as you can see, it's not quite lined up. So let's just actually bring it down a little bit. And then to the right. And let's scale the radius to, let's see, 75 maybe. Okay, let's try 76, 77, 78 is, I think, a pretty good number. Yep. So all of these can be 78. So let's just actually select all of them. And this should be 0.78. And then do the same thing by moving these guys over. Okay, so that should be pretty accurate. Now, if we were to run this, we're not going to see the wheels turning or anything, although we'll see the vehicle move. We're not going to be able to see anything beyond that. So yes, we can see the wheel collider turning, but when we are turning, our front tires are not turning. So let's actually write some code to fix that. So let's go back to our Visual Studio. So here's where we're going to actually update the mesh. And to do that, we're going to need a quaternion. And let's call this quat. And we need a vector, vector 3. And this is the position. And what we're going to do is we are going to get our wheel colliders. I dot get world position. This is going to output two variables for us, and the first one is going to be a vector, so that's going to be our position. The second one is going to be our quaternion. This is going to have the rotation, so it needs to be identified as an out because it's a out. And then now what we're going to do is we're going to get our we need our actual mesh, our wheels, right? So to do that, we can go back up here, and similar to the way we did with the wheel colliders, we'll do the same thing, but for our wheels. So this is wheels are going to be a game object, so it's going to be an array, and we're going to call these wheels, or we could just call it wheel mesh. It's fine too. And then down here on the bottom, we just need to make sure the indexes of our wheels match our wheel colliders. So then we can go and say wheels transform position equals to our the variable that we got from our wheel collider, and do the same thing for the rotation of our vehicle. So this is going to be transform dot rotation, and this is going to be our quaternion. Okay, so this is pretty much all we need to do is to now actually move our mesh. So let's go back to our game, and now we need to select our car frame once Unity is done. So now we have our wheels, and let's do the same thing, add 4 in here. We just need to match what we have on top. So our front, oops, so front right, it's going to be then our front left, and then it's going to be our rear right, and then it's going to be our rear left. There we go. Okay, so this should, let's save our scene, and this should work. So let's go ahead, click run. So now we have a vehicle that we can turn, and the wheels actually turn, and we can go backwards. So let's see what's our vehicle. Our vehicle dropped off the scene. That's not a problem. But as you can see, we now have a pretty good setup, and that we can move the vehicle forward, backward. Very good proof of concept. This should be pretty good for now, and our next video, what we're going to do is we're going to go ahead and make this a little bit better using Blender and doing some modeling and create a very low poly vehicles so that we can test and maybe create some tracks for our vehicle to test and see how it behaves on the tracks. And put some other values to it to brake and to have like a maximum speed of the vehicle, and then we'll go over some of the wheel collider values to what this mass means, what the radius means, what the wheel dampening and all that stuff actually means. Thank you for watching this tutorial, and hope that it was helpful and fun. We will make this code available to you in the description. As noted earlier, in the next tutorial, we'll complete our knowledge of wheel colliders and create a simple racetrack with a vehicle to test, perhaps maybe a few more vehicles to make sure we have everything covered for you. Thank you so much.